In this video, we are going to see about a repulsion motor. It is one of the special electrical motor, and it is operating under single phase AC supply. Hence, it is also one of the single phase special electrical motor. Now we will see the construction of repulsion motor. Let us assume two pole 24 slot stator configuration, and the main part of the repulsion motor is stator, rotor, commutator segment and brushes. The stator consists of stator core, and the inner periphery of the stator core has several slots. I have taken 24 slots, and we are accommodating the stator conductor in it, and then the stator winding. Okay, the stator winding is distributed short pitch type. Generally, the winding in all the AC machine is following short pitch type only. I have uploaded the video regarding the pitch factor. That video link also I have given in this description box. If you are seeing that video, then you will get to know why short pitch type winding is used in AC machine and full pitch type winding in DC machine. Okay. And also for obtaining smooth sinusoidal EMF waveform, conductors are placed in several slots. Okay. So the conductors are not accumulated together, all are spreaded over it, and so that is nothing but distributed. And next you have to see the construction of distributed and concentrated type winding. Then we have to see the rotor construction. The rotor consists of rotor core and the rotor armature winding. The winding is accommodated in the rotor slots. The rotor core is mounted on the shaft. The armature conductors, one end is connected to the commutator segment. The brush is also mounted on the commutator segment. So the rotor of this motor looks like a DC motor armature construction. Therefore, constructionally, the repulsion motor is combination of single phase induction motor. Yeah, single phase induction motor configuration is followed in the stator side, and DC motor configuration is followed in the rotor side. Okay, so the brushes are shorted together by a low resistivity material, conducting material. So that is the main difference from the conventional DC motor armature construction. And so and also it will works on the principle of electromagnetic induction and repulsion. To understand the working operation of repulsion motor, in this diagram I have marked a star and cross symbols. Already we know that is the current which is coming out from the conductor means that is represented as dot symbol. If the current is entering into the conductor means that is represented as cross symbol. Okay, that we have to follow the reverse symbol in the rotor side. For example, now in the stator side I have taken dot symbol in the upper portion, and the bottom portion is cross symbol. But in the rotor side I have taken reverse. Okay, upper portion is cross and bottom portion is dot. So the reason of choosing the reverse polarity, reverse symbol in the rotor side is we are giving single phase AC supply in the stator side. Then alternating current will flow through the stator winding. After that it will develop alternating flux. So alternating flux will be developed in the stator side. Then according to the electromagnetic induction principle, the whatever alternating flux developed in the stator, it will enter into the rotor and it will induces EMF in the rotor side, right? So that induced EMF is going to occur across the armature winding, armature conductor, which is accommodated in the rotor. So according to the electromagnetic induction, we are getting EMF. That EMF always will oppose the cause producing it. So the induced EMF, here EMF is going to induce. For that the cause is supply side. So this will oppose the supply voltage. That is why whatever we are assuming here, we have to follow the reverse symbol in the rotor side. Okay, and we have to take three cases for explaining the repulsion motor operation. So we have to see that. Why we are going to see three cases means because after getting supply as it is, this motor will not rotate. We have to find the suitable position of the brushes on the commutator segment. Okay, so that is why I am going to take in the first case alpha equal to 0. Okay, in alpha equal to 0, the brush axis is always aligned with the main field axis. These are all the main field. Okay, north and south. Okay, so there are two closed loop we can observe. Okay, there are two closed loop, and these are all the conductor, armature conductor accommodated in the armature side, that is rotor side, and EMF is going to, that is some EMF will going to induce in the rotor conductors, that is represented as cross and dot symbol. Okay, now what will happen if we have to see one of the closed loop? There are two closed loop, we have to see one closed loop first. So if you are seeing upper, that is top portion, there are 8 conductors, but there will be some EMF, right? So if there is a EMF will causes some flux in the armature. That flux is nothing but armature flux, phi A. Okay, armature flux. So this armature flux, now what will happen? Now this produced flux strength will push the corresponding conductor towards the main pole which is nearby it. See, south pole is far away, but this pole is nearby. So that is why that conductor will move towards the north pole. So the direction is like that. And the remaining cross symbol conductors are going to move towards the main south pole. Okay, like this direction. These conductors are moving towards this north pole, and these remaining 4 conductors are moving towards this south pole. Okay, here that is why we are getting 4 different directions. Now if you are seeing finally the net torque, that is the net torque will be 0 here. Both of them opposing nature. Here also in this brush side, these two arrows are opposing with each other, that is net torque will be 0. Hence we can say at alpha equal to 0 degree, if we are keeping our brush position at the same collinear position, collinear axis, then the motor will not rotate. Okay, it will be in stationary condition only. Now we have to see the 90 degree. So alpha equal to 90 degree. So from the main field axis, I am keeping my brush axis exactly at 90 degree. Now what will happen? There will be a 2 closed loop. If you are seeing left side closed loop, there are 4 cross conductor and 4 dot conductors. Okay. So this conductor having these 4 conductors having some EMF, and these 4 conductor also having some EMF, induced EMF. Both of them opposing nature, because these are all entering, and this is away from the conductor, coming away from the conductor. That is current will be away from the conductor. Okay, so that is why both of them opposing nature. So net EMF will be 0. Okay, net EMF will be 0. And if you are seeing the right side, here also we are having equal opposite symbol, right? Cross and 4 dot. So EMF whatever going to induced across this conductor, that will be in the opposing nature. So that is why net EMF here also 0. So if EMF is 0, then current will be 0. Armature current will be 0. Then torque developed in the armature is also 0. Okay, that is why at alpha equal to 90 degree we can't drive the, we can't get motion in the repulsion motor. Okay, and we are going to see third case, that is alpha equal to 45 degree. From the main field axis, I am keeping my brush axis with 45 degree displacement. Now we can observe two closed loop. It is one thing, and another closed loop is this side. So if you are seeing this side, there are 8 conductors, 1 2 3 4 5 6 7 8 conductors. Among this, 2 conductors are cross and 6 conductors are dot. So there will be EMF in these 2 cross, and here also across these conductors we are getting EMF, E. Okay, we are getting EMF. Now that EMF will produces flux, and every EMF will produces flux, right? The direct flow is from the EMF we are getting current, and that current will causes flux. So by the EMF we are getting flux. So we are getting flux in the armature conductor side. Now that flux will try to move the crossed conductor towards the north pole, right? And this dotted conductor is also moving towards the north pole. Now there are 6 dotted conductors, and here there are only 2 conductors. So here the flux strength will be more, because in every conductor having some flux. So the flux strength will be more. So net direction will be, it is dominating nature. So clockwise direction is dominating compared to counterclockwise. That is why rotor is going to rotate in the clockwise direction. Okay. Now we have to see this portion. Here there are again 8 conductors, 6 cross and 2 dot, and the flux developed by these conductors will try to move these conductors towards the south pole. So the direction will be clockwise, and the dot conductor will move towards the south pole. So that direction will be like this. Now this movement will dominating by this one, because the field strength will be more here. There are several conductors, right? So here field strength will be more. So the net direction may be clockwise only. So finally what we can say, either if you are comparing this side, or if you are analyzing this side or this side, whatever it is, finally the rotor is going to rotate in the clockwise direction only. Okay, if you are shifting the brush axis from the 0 to clockwise direction at 45 degree or 30 degree, whatever it is, we are getting, that is the rotor is going to rotate in clockwise direction only. Okay, so like that is what we were observed here. And another thing also we can say, we already said there are 2 working principles. One is electromagnetic induction principle, like that way only we are getting EMF in the rotor side. And another working principle is repulsion. After getting induced EMF in the rotor, there will be a flux, right? That will produce flux. If there is a flux, that is represented as pole only, north and south pole only. Okay. So after getting magnetic field strength in every conductors, we are having, that will become magnetic pole, that will become magnet. Okay, so it will act as north, and this one will act as south. So what we are saying, the same poles are ripple with each other. So north, stator north and the rotor side north will ripple with each other. Hence the motor is going to rotate in the clockwise direction. Okay, so it is move away from the main pole. This side also, stator side south pole, and rotor side is south pole, right? And according to this rotor brush position, we are analyzing the nature. Now this rotor will come away from the main stator pole. That is why we are getting clockwise direction. Okay, likewise we are analyzed then. And thank you for watching this video.